Hello, today we're going to talk about moments. So a moment is the moment of a force, really, is the tendency of that force to cause a rotation of a body in the form of an angular acceleration. So if we imagine we've got two blocks sitting here on an icy surface, we've got block A and block B. If we push on the center of block A, we can imagine it's just going to kind of slide along and not rotate at all. However, if we are pushing on the corner of the box like we are for block B, this is going to cause a moment to be exerted on the box. So if we imagine pushing on the corner, it would slide forward a little bit, but it would also start to rotate. And so that force causing the body to rotate is caused by the moment of that force. So moments, just like forces, are vectors. They have both a magnitude and a direction. And so we can imagine the magnitude of this moment is related to the degree to which this force is going to cause an angular acceleration. So the faster it's going to cause that angular acceleration, the bigger the moment that this force is exerting. And so the magnitude of these moments is measured in units of force times distance. So Newton meters or foot pounds. All right, so the direction of the moment is represented by the axis of rotation. So in 2D, things can rotate in only one of two ways. They can rotate clockwise or counterclockwise. But in 3D, you can imagine we can kind of rotate like this. We can rotate forward and backward. We can rotate about our center. There's a bunch of axes of rotation, and we need to indicate that with our moment. And like I said, positive or negative moments, if we've got one axis of rotation, so I'm rotating about kind of the axis that's going right towards the camera here, I can go clockwise or I can go counterclockwise about that axis. So in 2D, we're going to talk about this first. We need to choose a point that we're taking the moment about. So imagine we've got this body here and we're exerting a force on the center. And we need to choose a point, let's say point A. Maybe this is like a door. We're looking down on the top of a door and we've got a hinge here. We want to know the moment that this force exerts about the hinge of the door at A. So the magnitude of the moment is going to increase with not only the magnitude of the force, so the larger this force, the more rotation it will cause, but also the further out I am from my point, the larger the moment is going to be. So if I choose a point closer, like point B, if I moved the hinge over here and I'm holding this point down, since this moment is this force is a lot closer, the moment is going to be smaller. And also, if I choose a point, I can also change the direction of the moment. So imagine I've moved my point, I moved the hinge of the door over to the other side here. Now, rather than the door opening kind of counterclockwise like this, if I move over and I've got the hinge at C, my door is going to open clockwise instead of counterclockwise. All right, so moments in 3D. In 3 dimensions, we need to define not only direction. So 2D, we had clockwise or counterclockwise. That's the only ways we can move. But in 3D, we also need to define the axis of rotation. So the moment vector, the vector we use to represent this moment, will travel along the axis of rotation. So if I imagine I've got a plane here, this is a good way to demonstrate kind of the axes of rotation. I've got this plane. It can rotate about kind of the vector going out of the plane, and that would be considered roll in a plane. Pitch is going to be, if I've got the line kind of going from fingertip to fingertip here, and if I rotate about that axis, I can tilt down, I can tilt up, and that will be another axis of rotation. I can be positive or negative about that. And then finally, yaw, if I've got a vector or a line going straight down to my head, to my feet, I can rotate about that axis, and that will be a third vector. And really, there's any number of lines that I can rotate my body about. And each axis of rotation is going to correspond to the moment that would cause that angular acceleration. So to determine the direction, we're going to use the right-hand rule. So the right hand rule states that if you take your right hand, you're going to curl your fingers up. And so imagine I've got kind of this roll. So if I'm rolling like so, I point my fingers in the direction of that roll, and my thumb is going to be pointing in the direction of the moment vector. So if I'm rolling this way, I point my fingers that way, I know the moment vector, I've got my thumb, it's sticking straight out. The moment vector is going to be pointing straight at the camera right now. So that's how we determine what the vector is. Similarly, if I have a moment vector, I can point my thumb in the direction of that moment vector and kind of curl the fingers of my right hand around, and that'll show me the direction that this moment is kind of forcing the body to accelerate along. So with that, that's all I have for these slides. Thank you for watching, and I hope to see you again.